Example 2. This time, ooh, look at that. Cubic, but if you remember back from the first semester, we can factor this by grouping. And so I'm going to group these terms and these terms, and I'm going to see what we have, because this is just too similar not to try grouping. I have x squared times x plus 2 minus 1 times x plus 2. So altogether, this is x squared minus 1 times x plus 2. And I'm really thinking of this. Man, this is just getting really long. X plus 1, x minus 1, x plus 2. Okay. In the numerator, this factors as x plus 2 and x plus 4. And you might notice that we have a common factor when I move this up here of x plus 2. Both in the numerator and denominator, there's a common factor. And when that happens, I get really happy because I get this satisfaction from crossing these out. It just feels nice. And I'm left with a linear term over quadratic, which we just saw a second ago. So we have a general idea what those could look like. We'll see if this one fits the same mold. So I'm going to cover up some of my work that I just did, only for the sake of space, and leave that there. You can rewind the video if you need to go back and watch me factor so masterfully. So we're going to go through this a little faster. X-intercept is going to be found by setting the numerator equal to 0. So I have -4, nothing. My y-intercept is setting x equal to 0. So when I do that, I have 4 over 1 times -1. So I'm putting in zeros here and here and here, right? So I have 4 over -1, which is -4. That's weird. My vertical asymptote, I have actually 2 of them. It's set the denominator equal to 0, and I do, and I have x equals -1 or x equals 1. Both of those are vertical asymptotes. Horizontal asymptote, this is where we take the limit. Now I can go back to this original thing, or we can go to this. If we look at the factored form, we have to at least multiply out to get x squared over x. No, I just did that backwards. X over x squared, because that's what would happen down here. We'd have x squared minus 1. Here we have x. I guess I can write that. But we're only looking at these leading terms, so I didn't really care. If I put infinity in the numerator and the denominator, we get infinity over infinity squared. And those cancel kind of, and I get 1 over infinity. It's annoying, that little thing trying to jump out saying, hey, let me help, which is 0. So I have another y equals 0 horizontal asymptote. That's not always the case. It's just the case with the examples I picked, and now I regret it. And then I have holes in the graph, or at least a 1. So the location of the hole, I go back to the original, get rid of this for the end behavior. Original, or the simplified, not the original, simplified function. And I am going to evaluate the thing that I canceled. I canceled x equals -2. Okay, so evaluate canceled, or is this a common factor, right? So I'm going to plug in -2 in the numerator, and I get -2 plus 4 is 2. If I plug in -2 in the denominator, I get -1 times -3. And that all gives me 2/3. So I have a hole at 2/3. No. I have a hole at -2. That's the x value. That's x. And then 2/3 for y. There's a hole there. So I have all my 5 things. The only other thing that we could really talk about is domain and range. Maybe I'll do that in a second if I remember. So good luck with that. And I'm going to sketch a graph. And I know that I have a point at -4, and I have a point at negative 4, 0. I have a point at 0, negative 4. I have a vertical asymptote at negative 1. I'm going to, this technology is going to be great. I have a vertical asymptote here at negative 1. And also at 1. Probably about there. Okay, so that's a little bit tight. I probably could have picked a better scale. Let that be a lesson to you. But I know because I have this x-intercept right here, I know that, oh, I have a hole at negative 2, negative 1, negative 2, wait, negative 1, negative 2 right here, and positive 2/3. So I'm going to put it right about there, and I'm going to make it just an open circle. And that gives me a general idea what that looks like. And then when I go back to my horizontal asymptote, that was y equals 0. Makes me question everything I know. All right, so I have that as my asymptote. Now, normally, it's going to approach the asymptote. This might be an odd one. But I'm going to be checking that when we look. I just made this up. I multiplied a couple things together, and now maybe that wasn't the best thing to do, kids. Anyway, I know I have to I'm going to cross that asymptote, but I'm going to approach it also. And it looks like I'll probably be approaching from the bottom side and then cross and move up. So that's what I'm going to do. But it can't just, this is beyond, like, to know exactly how far this goes. To know how far this goes down before it goes back to the asymptote, because this is what's happening. It's going to go, whoop, oh, nope. I'm going to go back to my pen. That's going to come down here and get closer to the hole. And then it'll bend over here, and then it'll cross, and it'll probably loop down and then come back up. But there's no way we would know how far down it's going to loop. Like, there's a little momentum kind of that carries it through there, but it can't hit the axis and then stay close to it. It's going to drop and then approach it. But that's close enough for us. If you just something approaching, don't go too far away from the asymptote. And then on this side, I know there are no x-intercepts. I'd have to test a point, like maybe I plug in 2 into this. Now it's 6 and 2 and 1. All those are positive, right? Like if I'm plugging in 2, I have 6 over 3 times 1. And that's 2. So at 2, I'm at 2. That gives me a point that I'm kind of aiming at, and I know that I'm going to go through there. Okay? And then at this point, I know that I'm going to come up and hit this. What I don't know is if I'm going to bend and keep going. Actually, I know I won't. There are no x-intercepts in between here. Because there are no x-intercepts anywhere between negative 1 and 1, there aren't, we only found the 1, it can't keep going up, or we would have found another x-intercept. So I know this has to come up, get the y-intercept, and go back down. And that is awful, but I'm not good with this heart tablet. So there you go. This would probably be a little bit smoother. Oh, I just ruined it. Just pretend like that didn't happen. All these are functions, kids, and they would pass the vertical line test. And I'm sorry for any that don't. Oh, that's so bad. Really tricky to draw with this thing. But that's about as good as it's going to get. All right, there you go.